Around the time that I built the Tricopter, I decided that I was going to build a racing quadcopter immediately following that. However, about 2 years later, I'm finally getting around to it. When I got the motors for the Trifecta, I also bought 4 extra. So these Sunny Sky 2205 motors, I think they're 2205, 2207 motors, are ones that I bought at the same time as the ones for the Trifecta. And about 6 months later, I bought a KISS EFC and ESCs for the racing quadcopter. But things have moved on. So what I'm going to use now for the flight controller is this all-in-one. Now, for those that have watched the Trifecta videos know that I had a separate OSD, separate video transmitter, separate flight controller, separate power distribution board. This has all of those in one. So it's going to be interesting. I've never used one of these before, and I'm going to marry it up with this XSR FR Sky receiver using S-Bus. At least that's the intention. We'll see how it works out. And the frame I'm going for is this body frame, which I bought from Bangood. I'd originally intended to go for either an Armatan or an X-Hover frame, but they were quite expensive, and as I don't know if I will enjoy flying quadcopters, or at least racing quadcopters, I thought I'd go for something cheaper, and I can always move the electronics across to something else later on. In addition, I am using these ESCs, again from Bangood. They are very, very, very small. These are 20 amp ESCs. And when I compare them to the ones that I use in the Trifecta, they are, well, a third the size, and they don't have a whopping great capacitor on them. Which sort of concerns me slightly. I'm wondering how they provide the same functionality. I have rubber mounting grommets, standoffs, which I'm going to put on the flight controller, and this is the frame. This is not the bag the frame came in. It was kind of dusty. So I emptied the parts off, washed them, and with some wet and dry abrasive paper, soaked, and with plenty of water and wearing gloves, I just took the abrasive paper just around the edges to make sure there's no splinters, no dust, nothing that would irritate. I didn't really round off the edges, but they're not as sharp as they were. That's that. It comes with some aluminium side pieces. There's the ESCs. I also got these. These are ESC covers. Right. But compared to the size of the ESCs, where did I put that ESC? Open, so let's pull this out. Compared to the size of the ESC, these things are whopping. So they may be too big for the size of the arms. Just about. But what I think I'll do is I'll just use some insulation tape and wrap it round. So I'll actually go that way. So I'm going to make up the frame and report back on how it all works out. Talk to you soon. Just a quick test flight in my front garden here after 2 aborted test flights at flying fields. One where I got soaked and the other one where the wind was 20-25 miles an hour. Not something I want to maiden on. Default Betaflight PIDs and rates on the quadcopter here. Line of sight flying, even though there's FPV footage here. I've got the goggles recording, but I'm not using them. A lot of expo on my transmitter and low rates on the transmitter as well. Quadcopter seems to be responding quite well. Here we are. This is the completed Fatty quadcopter frame, complete with the HGL RC F4 V5 Pro board. As you see, there's a lot of space in there. I've got the Runcam Swift mounted at the front. It's sporting Sunny Sky 2207 2100 kV motors, an LED strip at the back. This wasn't mentioned at the start, but it's sold as a spare part for a Talon. I've set up the LEDs simply to be green when the quadcopter is safe and red once it is armed. The ESCs are sold as DYS ESCs, though there is no markings on the PCB or the label to indicate that that is the case. They were very easy to wire up. They have motor contacts in both the upper surface and lower surface. So with the wires coming straight out of the motor and wired to the terminals on the upper surface with the label side up, the motor turns in the normal direction, which is anti-clockwise, counterclockwise, and soldered to the terminals with the label side down, it turns the opposite direction, clockwise. So very good for quadcopters. The battery strap I'm using is not the one that came with the quadcopter. I found that too large. And I'm not using the slits on the bottom frame for the battery strap, but putting it right through the entire quadcopter frame. It seems to suit the batteries I'm using, and I think there's plenty of space there even if I do upgrade to 4S at some stage. It's currently a 3S one I'm using. The whole thing went together very, very easily. The only issues I've had are with the standoffs. The bolts that came with the frame are to mount the flight controller board are 16mm, and when I put the rubber standoffs on and screwed them down as far as they'd go, there was a gap of a couple of millimeters. Not a problem if you've got a separate PDB, because the power distribution board would lift it up sufficiently that they would be the right length. The flight controller board that I'm using is slightly larger than normal ones and extends both to the front and to the rear, and that's where the motor terminals are, the motor connections. And with those bolts and normal nuts, I found that the motor terminals were very, very close to the Runcam at its lowest angle. So I decided to actually remove the nuts, put in shorter bolts, and just have the standoffs mounted directly down on the frame. That now gives me plenty of room. The other minor issue I had was with telemetry. I wanted to use telemetry for two reasons. Telemetry is a good thing in general, plus with OpenTX 2.20 and the Betaflight Lewis script, you can actually view and modify your rates and your PIDs on your transmitter directly. So that sounds like a good thing to have as well. The problem that I had was most F4 boards are supposed to have a smart port connection, because smart port telemetry is inverted, and this one didn't. So I followed a video put online by Project Blue Falcon that explained how to modify the XSR receiver that I'm using to get the non-inverted telemetry, basically by soldering a wire onto the end of a transistor on the receiver. That's working very, very well. If I'd known how easy it was to invert the protocol just using the Betaflight's command line, I would have gone that way instead. One simple command and I could have used the smart port connection. A lot of people in videos object to these direct connections because it's a straight connection, and the problem is if you wire directly to this, if they have a crash, the battery could fly forward and this could get twisted off. So that is why I have built this little right angle connection. It's wired together. I've used coat hanger wire to provide strength. That's a steel wire soldered between the terminals, and I've backed that up with copper wire running in parallel to provide the conductivity. So when the battery flies forward and it pulls out, it should not damage the board. Even saying that, I have found that it does twist. Well, that's it. Hope you enjoyed this video, and talk to you soon.